Okay. Yeah, because also what I'm doing is because it was my mistake and I forget. I was I'm recording that seminar because also maybe some of you, Mr. Ovidia, can forward it to you if you want a copy of this seminar. Okay, let's continue. We go to introduce the name of the project, a description, any kind of description, and we go accept. Okay, first of all, we have several options to introduce a project. We can introduce from an empty job. We can import from Metal 3D. As I explained you before, we can import a steel structure. We can import from DXF or DWG. That it means the most common is we can import from AutoCAD. That we can, if we have the structure already introduced in AutoCAD, we can import the whole structure in the software. For that, the only request is that we used to say to have clean drawings. Clean drawings, it means that we have to, in the AutoCAD file, we have to have one layer for the columns, one layer for the beams, one layer for the openings, and one layer for the fixed points. And then we can import the whole structure. Also, we can import from IFC. That it means like a BIM software or 3D modeling software, like ArchiCAD, Allplan, Revit Architectural, and any type of software for BIM or IFC, and it's called 3D modeling. Any that because the type of the file is IFC, then we can import also a 3D modeling also directly. Today we go to do it on the hard way. We go to do it from an empty job, and then we go to accept. Okay. First of all, we have the general data, or we can say that is the settings for the project. Then for that we have here the codes, and we have first of all for concrete. For concrete, we have all these several different regulations for concrete. In this case, we have for Spain, for Brazil, Argentina, USA, Chile, Mexico, Eurocode, South Africa, the annex for Bulgaria, for France, for Romania, in this case, France, India, Peru, Russia. We go to select, for this example, Eurocode for Romania. For cold form steel, we go to select Eurocode 3 and 4. Also, I have to tell you, with the help of Mr. Ovidio, our development department, we are working already in the implementation for the Romanian annex for cold form steel and for rolled steel. That I suppose that it will be already released in around, probably in around April. I mean, in a couple of months, I think we are already in situation that this annex for Romanian, it will be already done. But we are working on it. I mean, we are working to implement all the specifications or the particularities for the Romanian market. Also, we can select the different type of regulation. Also, this is very helpful if we have, or sometimes we have overseas projects that we can handle, or we can be capable to do projects not only in our country. Also, we can be capable to make agreements or a collaboration with engineering all over the world, and in this case with conform steel, rolled steel, timber, aluminum, etc. Okay. Once we already select our collection of codes for this example, we can introduce the quality of the material. In this case, it will be for the floor slab. We're going to use BC30 or foundation or columns 20 or the same type of in all of them, for example. Also, we want to aggregate properties by the nature and depending on the soil. If we want to make difference. Well, for this option, I'm not going to spend a long time on the settings. But what I can give you to have a general idea that we have many options for the settings that when we introduce these settings the very first time, usually when we introduce these settings, when we open the software again for the second time or in a new project, the settings that we already modify, it will be kept as a default settings. One thing, then we don't have to introduce all these settings every single time. Only we can introduce one time and it will be the same settings every time. After that, if we want to modify, of course, we can do it. And also, with these settings, it gives us, in the analysis, later on the analysis, we can achieve better results in the terms of accuracy of the results. It depends how we modify the settings. But in this case, we go to do it as a standard way. But also, I want that you can see some different type of settings that we have, like we can verify the footing sliding, we can change the parameters, we can introduce the percentage situation, also in the masonry walls. And for the steel, that also is very important, like we can introduce the tables for the reinforcement. That it means that here, for example, in the beams, in the top reinforcement, we can, the bend top reinforcement table, we can select the type of the tables that we are going to use. Also, we can edit that tables, we can change that tables, we can delete. For example, if we are not going to use the bars of the 10th or the bars of the 20th, we can delete. And then when we do the analysis, because we introduce automatically the reinforcement, this type of diameter we are not going to take in on consideration. Also, if we have our own libraries or if we have our own type of reinforcement, we can import and we can work on it. Maybe we have a special agreement with a factory or we have an excedent for another job. Whatever we want to do it, is possible that we can select and then we can modify that tables for reinforcement. This is as an example. Okay. Once we already introduce the type of the reinforcement, sorry, we can leave it like that. I think it could be like that. I go to accept and accept. Also, we can introduce the limit states for this project. In this case, it will be based on Eurocode. And now we are in situation to start. Okay. First of all, we go to show you that we have here different tabs of the bottom. That the first two tabs is for the introduction of the elements. That it means that the first tab is for the vertical elements. The second is for the horizontal elements. And the rest of the tabs are for the results. And here, like every Windows software, we can go in the toolbar from the left to the right in all the options. Then it's very easy to not make mistakes. Almost in the very first times that we are using and we start to have the skills that we know with blind eyes all the options. Here we have file, new, file manager, we can say job, the general data is already, we already introduced. We can import and export. In this case, we are not going to import, we're going to do it from zero. Now it's introduction. Introduction of floors. Okay, we're going to introduce new floors, single. Then we can introduce the 8, it will be 3 meters, and light load and dead load. And also we go to select 3 floors. Okay, we already introduced the 3 floors for this simple example. Okay, once we already introduced the floor, well, what we can do is to came back because we already now we know how it will be the shape of the building, how big, how it will be our example, and we can came to the general data. And now, because we know the age and the shape of the building, we can introduce the wind load, for example. In this case, this is all the type of wind loads that we have. We have a Eurocode, of course. Also, we are working as we are doing with the regulation for Romania. We are working for the introduction of the wind loads for Romania, in this case, specifically for Romania. But in this case, we can use Euro codes, and we can set tributary width would be 6 by 6. Always, we can introduce ourselves, we can change the value and introduce our wind speed, and also we can introduce by direction. Also, we can modify the terrain category, and also we can select, it will be the orography. It will be ascending or descending, or in a hill or flat, in both axes, in X and Y. If we want to take in consideration with or without second order effects, and we accept. Okay, here we already have the code for the wind load. And for the seismic load, exactly the same. But in this case, we already implement the Romanian code. Here we have the Euro code. Also, we can select the general method that we have many spectrum typologies that we can use it, or we can introduce our own spectrum. We can create for the seismic loading by period or an amplification factor, or in this case, we can select for Romania. For Romania, with that regulation, also the behavior of the coefficient, we can change the value, if it's regular, the height of the geometry, or irregular, the acceleration of the soil. And also, we have here the map from Romania with the different type of seismic regions. And also, it depends on which region we select. We can select like here, and also we can select the, in this case, the area or the city. For example, in this case, Sfântu George, for example, that I think it will be the one we can select. Do you wish to assign the selector for Sfântu George? We can say yes, and then automatically it's already changed to the 20. And the zone, it will be managed, or the reduction factor. Okay, also we can modify the vibration modes considered on the analysis. It could be based on the code, it could be automatically that, for example, we can change and we can modify the percentage of the displaced mass where it's reached. For example, in this case, 90%. That is quite optimum. And also we can change the modes by floor. Then in this case it will be 6, it could be 8, it could be whatever we want. Also, if we want to consider the floors or below ground level in the dynamic model or not, instead I want to introduce. Also here we can check anytime the design spectrum that we are selected for that job, and we want to consider with or without second order effects. Okay, and now we can accept. And now we can see that what are the regulations that we are working right now, and the criteria of reinforcement by utility, and also if we want to consider the construction elements. It depends of the country or the area. It could be interesting. In this case, we talk about soft stories, that it will have to take on consideration a soft story in any of the cases, or if you want to consider 1 or 2, whatever. And also, we can change this option, that is the interaction with the structure. Till today, or till a few times, this is something that we already developed, our company. We take on consideration the structure in the seismic condition. We have this consideration of the facade of the building, we can say like that, like the external walls. And now we already also have in consideration the internal partitions. Then on the analysis of bioseismic, if we want, Also, we can take on consideration the internal partition. The only limitation that we have for that right now, and also we are working to make improve on that, is that have to be between two columns. I mean, that partition have to be between two columns. But this internal partition, that it could be the rooms, toilets, kitchen, whatever type of partition in a single building, we take on consideration on the analysis for the seismic, for example. And this is something that we implement recently. Okay. Also, if we want to apply, in this case, more load cases, we can modify here. This is the ones that we already have right now for the same way that they load, the live load, the wind, and the earthquake. Also, we can introduce additional load cases and load parameters. But for that example, it will be enough. But also, as I told you, I remind you that all the options, we can change the value, and also we can modify the settings to have a more effective, a more accuracy values on the first results. Okay, we already introduced the floors. We already have all the regulation that we are going to introduce, and let's go to introduce the project itself. For that, probably it would be very helpful for us to import a template from AutoCAD, for example, or a template for any drawing or any CAD software. In this case, I select implemented that. Here I have this is my computer, the folders I have it. I have here one folder called drawings, and I have these two drawings, and I select, I open it, and I accept. And here I'm already import this template to use it, these drawings, to use it as a template. And then for the ground floor, for example, I want to unselect all the layers, and for me, I only want the columns. And for the first floor, I want to unselect, I only want this one, columns, stairs, the wall, and nothing else. That's, for me, it's okay. And also, I want to assign for each group which template I want to use. For example, for the column definition, I want to use the ground floor. For the foundation, this template, and for the floor, this template, and this template. And I accept, and I accept. Okay, I'm ready to start to working on this. Sorry, this guy. Okay. Now I'm ready to introduce the structure. Now I'm come here, introduction. I'm already introduced the floor. Now I go to introduce the columns. In this case, will be new column. I can select the length of the column, that it could be from the foundations to the third floor, or to the second floor, or to the first floor, or also it can start on the first floor. Whatever we want, all the option it could be. Also, I can modify the buckling coefficient. Also, I can modify the fixity. And also, I can change the reference if it's with or without external fixity, and the shape of the column. That it could be round column, and I can introduce the diameter. Also, it could be, as I told you in the very, very beginning, steel columns, that even that the structure will be concrete structure, we can introduce steel columns. And for that, I can select here from a library. Here we have all different type of library. Also, if we can import our own library, but these are the most common worldwide type of profiles for steel columns. This is the type of profile. And also I can edit my own library, and here I can introduce the size of the profile, and also I can change here 85, and here it will be 5.2, for example. We can select the different measures for that. Cancel. 50, 45, okay. 45, okay, are incompatible, but let me see. Okay. Okay, cancel. Okay. That I mean that we can edit the type of profile that we have, or from a brandery, or from a factory, or the ones that we are used to work with, or also if we have a table or we have a library from ourselves, we can import a library and we can introduce automatically. Okay, also with this profile and with that one, with this one and with this one. And for this example, I'm going to introduce a square column. Also, it could be rectangular, but for this example, I introduce a 40 by 40, for example, and I go to accept. Now I'm going to introduce. I don't know if you see properly with this background. All of you can tell me you can see properly the screen that with the background on gray, or do you prefer that I can have to change the background color? Or for that way, it's quite okay for you. Okay, perfect. Then I'll go to continue. Okay, also go to introduce the column. Here, accept. And I want to use the snapshot option, and I go to introduce point, endpoint, center, and midpoint. Accept, and now go to introduce the columns. Like that, like that, like this, like this, like this. For me right now, I don't care if I'm not introduced in the right place, the column. The most important thing right now is I have to introduce in the right place the fixed point. And now also I can see it and show the dimension or not. Also we can see that the fixed point is already, but the columns are not fixed with the template on the right place with the template. Then what I can do is now I can first, after to introduce the columns, I can see also that I introduce the contours, the green lines. Also I can see the dimension or not. And for that also I want to edit the column. I want to select this one. This is the same menu that we had before, but here we have a new item that is the fixed point, that I can change here the fixed point, and then automatically, I see that I fix the column to the template. Then if the column after the analysis we see that have to grow, never is going to grow from that side, from this face of the template. And also, I can make this option that is called adjust. And then if I adjust the column, that it means that if I put the mouse more or less here, I adjust the column directly. Then, as you see, very easily, we adjust all the column on the right place. Then we already have all the columns introduced on the right place with the template. Okay, we can already introduce the columns. Also, we can introduce contours, we can introduce grid lines, show the dimension and modify the dimension, and here it will be the manual. In any time we can select the manual, and we have the manual to any kind of doubt. Okay, we already finished with the toolbar on the first tab, that is the column definition. Then we go to the second tab, that is the beam definition. Okay, this is the beam definition tab. Also, as you can see, we already have a different template because we select that for the first floor, that is here on the bottom, on the right corner. We see in which floor we are always working on it. Now we are going to introduce the beams, and in this case we have several options in the toolbar, but we have one called beams. Then beams, define a beam. Here is the different type of families that we have for beams. That we have flat beam, dropped beam, lattice beam, prestressed beam library. Also with external fixity, or waiting for definition, different type. For this example, we are going to select a dropped beam, and in this case, I'm going to select, for example, it would be 30 by, no, here it will be 30, and here it will be 50, for example, like this type. And I'm going to accept. Now I'm going to unselect this type option, and I'm going to introduce the beam. From here to here, like this. As you see how easy we introduce. Here I use the orthogonal. Okay. Okay, we already introduced the beams. Now, always we can see, I forget to show you, here we can see ground on material, a 3D view about what we are doing. And also, if I want to see on detail, I can see on detail what I'm doing. And I see that the beam is not fixed properly with the face of the column. And I want to adjust the beam to the face of the column. Well, and in the same or very similar as we adjust the columns with the template, we can adjust the beam to the place that we want. And here we can select adjust. If we want to put the mouse on that side, we adjust to this side of the column, and the same for that side. Or if we put the mouse more or less on the midpoint of the beam, we adjust both sides. Then, as you can see, we can adjust very easily all sides, like this one, like this one. And here, I want to adjust to this side and to this side. Also, let me see. Okay, perfect. And also here I have, it looks like a problem because I want to adjust this beam to the template. Then what I can do is I can use this option on the menu that I have nearest. And then what it means that here I can see that we have an option, and I adjust it automatically to the right place of the template. Okay, we already introduced the columns, we already introduced the beams, we adjust the beams, and now we have this question, like interrogants, to see what is that. We have to define the slabs. And in this case, we have slab, panel manager, define a panel. We have the different families. For every single use, every single option, we have different families, internal options. We can introduce joist floor slabs, whole core slabs, composite slabs. Here, let me see, like that. Composite slab, waffle slab, flat slabs, whatever we want to introduce. For this example, I'm going to select a flat slab, like 15, it's okay. And then I select this slab parallel to this beam, this one to this one, this one to this one. And here I want to introduce an opening for the stairs. Okay, I'm already introduced. Now I can want to introduce the loads. In this case, I can introduce a different type of load. I can introduce a point load, line load, surface load, with a different type of load cases, self-weight, dead load, or live load. And also, I can introduce additional load cases. We have an option to introduce line loads on beams. That it means that if I select, for example, all these ones, I introduce automatically the line load on the beam. And also, after that, I can delete. And I want to delete this one, this one, this one, this one, for example. And then I can only have the line load on the beams that I want to introduce that load. Okay, I'm already, we can say that in this case, if we have post-tensioned, also we can introduce, we reintroduce the beams, the labs, then we can go to the second floor. Okay, now we are on the second floor. Here, we can see it here. And we can introduce all the elements again, or in this case, I can copy from the first floor. And we can come to the third floor, and I can copy from the second floor, for example. And here we can see very easily how we already introduced this simple structure in this case, but in a very fast way, how we introduce it. Okay? Okay. Now, we already introduced the columns, the beam, the slabs. We introduced all the floors. And now we can come to the foundation. And here, for the foundation, we can select this option is like a kind of elevator. I come here for foundation. And I can introduce the foundation elements. Here I have an option, beams, slabs, posts, foundation elements, new one. This is the type of foundation that we can introduce: reinforced concrete footing, mass concrete footing, and pile cap. For every single use option, we have an extended menu for all of them. I got to introduce a reinforced concrete footing, and I accept. And here we can be on detail that if I dance around the foundation, we can see like a preview about how will be the shape of this foundation element. And then I can introduce it like that, and I can introduce it like that. And for foundation elements, I can introduce strap and tie beams. And here I have all the tie beams, strap beam, and automatically balance. And here I can introduce orthogonal like this. And also I can see the moment also on the foundation, on this strap beam. And I can select another option that is called generate footings and beams, that we can propose an option for the footings. Okay, we already introduced all the elements, and now we can do the analysis. We already finished. Now also here we have the analyze, including foundation or except foundation. In this case, I'm going to do including foundation on the hard way. That option, it means that because it's very common in our customers that also they have modifications on the project. It's very common that, no, it's not like that. I want to change this. I want to change that. I want to add a new floor, whatever, any kind of changes. That it means that we don't know 100% sure how will be the final shape of the building. Then for us, it's not necessary to have the analysis for the foundation. But once we already know for sure that this project don't going to be changes, and then we can have for sure the final shape of the building, then we can do the analysis of the foundation independently or with all the structure with the foundation as well. This is an option that also we can save time on that. Okay. Here we have overlapping foundation elements. We already finished the analysis, but before to check the analysis, I want to ask you if you have any questions till now. Then if everything is clear till now, I ask you to all of you if you have any question. Okay. Till now, do you understand, all of you, all the steps that we follow, how we do it, and everything? There's no questions till now, correct? Then, if there are no questions, then we go forward. Okay, I remind you, at any time, you can make kind of questions. Okay, perfect. Now, we go to see the results. First of all, that will be here on the foundations. Okay, this is the foundation elements. Here we can see that we have overlap foundation. This kind of thing sometimes happen when I do that. I'm not a type of engineer, good engineer, and then happen this kind of things. But anyway, we go to analyze this. Also, it's very good that you see that sometimes I make mistakes on propose, because I want that you can see that the mistakes, the program show you the mistakes and show you the problems and show you what is right and what is wrong. Okay, I come here Okay. I come here to the foundation elements, edit, and I want to edit, for example, this one. Okay. Well, I have here these foundation elements already. Also, I can see a 3D view of the foundation element here, and the detailing. This will be the detailing with the reinforcement. Also, I can here and see that we have 3 bars of 25, but if I come here and I can change to 12, I can see that automatically it's already changed. And now I want to see the checks. And here, yes. And here I have the checks for this. And also it says that something in red. It says the bending in the pad footing for the fixed combination that falls checks is not verified. And also said that the minimum geometry ratio have to be 16 and it's 7 and in X direction. Why? Because here the code article 9.2.1.1 says that have to be 16. Then also we show you when it's something wrong and why it's something wrong in the analysis. Okay. We are going to check again, and it was 25. Accept. I'm already changed it again, and I can see the checks again. And we'll see that where before it was something wrong here, and now it's verified, and it's calculated 28. Now we are on the regulation. There's no more problems on that reinforcement. Also, I can introduce, for example, top reinforcement, and I can introduce perimeter reinforcement, and I accept, and then automatically appears here the reinforcement, and also it changes automatically here, for example. Okay, this is for the foundation elements. And now we can come to the first floor, and here we are on the first floor. Okay, on the first floor, we can go to check, for example, the columns. Want to edit the columns, for example, and I can select this one. Okay, here we can see the column schedule and the column data here and here. This is the column data that also we can modify. If we can see that we are not accomplished on the regulations, we can modify, we can edit, we can change the shape. For example, here, like here, and like here. Also, I can change the diameter on the corner, on the top, in every place, for example. And also we can redesign. Then we can do many options. In this case, I want to leave it like that, like it was, with the minimum reinforce necessary. The overlap length addition, also here for the stirrups, and this is the percentage of accuracy that we have in that columns. Okay, this is for the columns. Also, we can have the same for the beams. Also, first of all, we can see that option is called beam errors, and here on the beam errors, we can see that the errors, where it comes from. And it said that the stirrups outside the table, for example. And now I can come here and edit the beam, and I can select this beam. Here it will be the design of the beam with the reinforcements. Already introduce it. Also, I can change the group, or I can change the frame. And for every single one, I can see it. Also, I can have the longitudinal reinforcement, the stirrups, lattice, infill, shear studs, and also we can add reinforcement, we can delete reinforcement, we can match, we can edit. For example, on the longitudinal reinforcement, I want to edit, and I want to select, for example, this one. I can change the diameter. I can change the length. I can change the distance. For example, accept. So I can change the length. Instead of 52, I want to introduce 38, for example. And it will be like that. It will be 380, for example. And it will be like that. Also, if I want to introduce here many options, or I can delete, or I can join, or many options, that here is when we used to say that you see how easy is the design of the structure. And here we can say that now is when it starts the work for the engineer, then to achieve the best results, to show the skills as an engineer, and to take the best accuracy on the results for that structure. Then, for example, if we can save steel, for example, on the bars here, instead the bar of the 20, we can introduce the bars of the 12. Then it's a weight of steel that will reduce. But this is only on that beam. But if we have 10 stories and we have, 35 beams per floor, in the total amount, it will be a huge amount of steel that we already saved, for example. Okay. No, I don't want to change the yes. Okay. This, we already see the columns, we already see the beams. Also, we can check here the reinforcement on the slab. We can modify the reinforcement, and also I can modify the width, because here this is the our best solution for the reinforcement on the slab. But probably also you know that this is not the best solution on execution, because it's more practical to have the same length of the reinforcement in all the slab. Then we can select from here to here, and then we can have the same length of the reinforcement very easily. We can select the reinforcement from here to here. Okay? Okay, we already see more or less all the situation that we see on the columns, that also we introduce the reinforcement, and we can modify that reinforcement. We can see the beams, that we can modify the reinforcement, you can check. Also the same for the slabs. Also we can see in the analysis point of view, we can check here the contour maps. That also it could be here for the displacements in any direction. Also we can see the forces in the total shear, in X and Y, the moment in X and Y, and in combinations. And this is all the combinations that we already analyzed. And then for every single combination, we can check how will be the forces in the moment. Also, we can see the design forces in persistent or transient or in seismic, in X and Y, bottom steel or top steel, and also there's no steel areas, sorry, and also the steel areas in any direction. Also, another option, the displacement, for example, also we can see here in the contour map, okay, the forces in beams. We can see the envelope on that beam, for example. In this case, I can forces in beams, and the scale, it will be 1, for example. No, forces beam, the scale will be 0.001. Oh, sorry. 0.1. For example, here we can see, we can change and we can modify the scale, and also we can see all the values for the envelope for the moment. And also we can see the deflection between 2 points. We can select from here to here. And we can have the value in the worst case combination, where it will be. Okay, this is on the contour map. Also we can see in combination here, and to introduce very dramatical option, then it will be, this will be an animation about how will be the deformed shape on that combination. And for example, this one, we can see the backing on the columns and the displacement here. Okay, we already see the deformed shape. Well, here on the results, sorry, also we can see here on the column, here results, envelope, the forces in columns, for example. I can select this one, and I can see at the elevation, the forces that we have applied on the column, in self wave, in dead load, in line load, and in the combinations. And also, after all the analysis, we can check, for example, the reports. Okay, for the reports, we can, the job data report, combination, foundations, report, forces in beams, for example, is the report similar to the one we already see, except, and we are going to see some reports, some examples of the reports on the project that I remind you that we introduced just in a few minutes. Here we can see, we can print it, the forces that we have. Okay. Also, I want to see the beam reinforcement report, for example, for the first floor. Here. This all the frame, the forces on the span, the moment. Also, I can see the beam takeoff. Very important. It's a bill of quantities of the beam, only for the beams. For example, here, I can have this table. Also, I want to show you that all the options here, all the options we can export to text format, HTML, PDF, WordPad, Word 2003, Word 2007, or also you can copy and paste, and you can put it in an email or whatever you want to do it, or you want to, one of your colleagues can check the results, and also you can send it to him. But here, and here we have the total summary of the takeoff, the bill of quantity. Now we can give to our customers how much it can cost the steel, how much it can cost, how much it costs the steel for the beams for that structure. But probably our customer also wants to know how much it costs the total job. And here we can have this. I can have the job takeoff, the bill of quantities in the first floor by slabs, by the beams, the formwork, and the top formwork by columns. And also, I have the values on square meters by surface, and Buller by cubic meters and kilograms. And here the total and the index per square meter. And this is for the first floor, for the second floor, and for the third floor. And here we can do right now, with a very high accuracy, a real bill of quantities for the project. To our customer, we can say, okay, this it will be the final bill of quantities for this project, on the concrete and for the steel. But we always suggest one thing, that it's, okay, we have this bill of quantities, we can print it out. And now we can come back for the columns, or we can come back on the beams, and we can change the reinforcement, because in some of the beams we can play with that. We go to see if, because maybe we have an excedent from another project, because we have reinforcement of another diameter that we have available, or a new factory or an old factory from steel give us a big offer if we achieve, I don't know how many tons of steel over a determined size of the bar. And then we can introduce these elements, and then we can give to our customer different type, different bill of quantities, and then to achieve better results. And then, okay, you have here the bill of quantities. I show you this one, and this one, and then you decide. Okay, also here we can have column displacement, column distortion, justification of seismic action. For example, here for the seismic action, the design spectrum, how we achieve the results, the parameters. Here, the participation coefficients, the center of mass and center of stiffness and eccentricity, floor by floor, and here a graphical representation of that. And well, we have some of all the reports that we have. And finally, at least but not last, the drawings. That, for example, I can select this one. I can select, for example, floor plans layout with the takeoff summary. Also, I can select this is column and shear walls. Here, floor plans, longitudinal top reinforcement. Also, here I can select floor plans, transverse bottom reinforcement, for example. Also, we go to select beam drawings here. Also, we can edit that. It could be by meters, with 2 decimal, with 3 decimal, without decimal, whatever. If we can customize, and also if we want to introduce some details, for example, I can accept like that, for example. And also here, column schedule. Also, we can configure the size, the thickness, etc. And let me say, okay. And some other one like conditional foundation load, whatever. Okay, I'm going to accept. And now, as you see, we already go to have all the complete detailed drawings from all this structure. When I say complete, I say final drawings. We don't have to worry about to do drawings anymore. And here we have the drawings for the project that we have here. With the bar bending schedule, frame by frame, floor by floor. Also, I want to repeat and remind you, we can edit all this. I mean, if we want to change the thickness, or if we want to modify the reinforcement, the length of the letter, here with this information. Also, we can select, for example, I want to show you, for example, if I want to modify, want to edit, and I want to edit this, for example. No, sorry. Okay. I want to move objects. Yeah, move object. I can change this object, and I can put it here. Yes, even it was a nonsense, but to see that I can play with that, and I can change, and automatically the drawings changes. Okay. This is what we do. Here also I want to see in detail this. The load cases for the foundations. Do you have any questions? Because more or less we already see overview about what we do, and also quite important how we do. And before the question, I want to say something because I forget, and it also is quite important. Okay, we have these drawings. No, I don't want to. Here, I have these drawings. I can select all the drawings that I want. But even that, also these drawings, we can export to AutoCAD. That it means that we can edit these drawings. As I showed you, we can change the thickness, we can change the length, the type of the letter, we can introduce a logo, we can introduce some elements like this kind of libraries that also we have in AutoCAD as well. But we can export this to AutoCAD. Here we can see in DWG, and also if we want to export to AutoCAD, and if we want to work with in AutoCAD as well, it's absolutely possible. Then it's a bidirectional, it's an open, it's not closed, it's not blocked. We can import from AutoCAD when we start, and we use this template, and after that we can export to AutoCAD as well. Then it's a bidirectional in the point of view that we import and export to AutoCAD, and our drawings also you can export to AutoCAD. In our experience, our customers, maybe the first times, they still continue to export to AutoCAD. After 1 week, 10 days, couple of weeks, they stop to export because they see it's unnecessary. It's a waste of time to modify a couple of details on AutoCAD because they can do it in our software, but if they want or they be more comfortable to do it on AutoCAD, we give that option. Okay, just export to AutoCAD and you can work on AutoCAD with our drawings as well. Okay, any of you have some questions? Do you have some questions from me, or from the project? Some doubts? Something that you want to clarify? Come on, don't be shy. Also, I remind you that you can have the chat option to do it. Gals, what do you mean curtain walls? You mean like a masonry walls, for example? Glass. Well, yes, you can simulate glass. You can introduce the parameters on the load, on the line load, for example, and an additional load as to simulate the behavior for that, but not like a wall. Yes, but it's possible. We do many buildings with that condition, like the completely structure of the building outside is made by glass. Yes, it's possible. And also, we can introduce walls, like here, like it could be reinforced concrete walls, plain stress walls, reinforced concrete block wall and masonry wall? Okay, but the answer it will be yes, it's possible. Also, I have here a question that Mr. Ovidio asked me, also implement P101 from 2013. What's that? This is the new annex for Romania, probably?
This is the new annex for the seismic code.
No, but I suggest you to not put the speaker.
Okay, I will.
Okay, because it's it's something happened that when you connect, it sometimes connect more than one, but it's okay. But yes, and it is about the implementation for the special annex for Romania. I explained in the very beginning that we already implement for the concrete and for the seismic. We are working right now to implement for steel and for wind. And if I'm not wrong, it appears a new annex, or recently a new annex for Romania. As soon as we have the details, we can working on it to implement. But it's not a problem. We can say that Romania is one of the markets that we are giving a push and to be implemented and to be well noted. And for that, we think that it's more than necessary to implement in the next 8 weeks, 9 weeks, all the regulation that it will be. Also, one thing that I want to ask you to tell you is this is the software that I show you today is the 2014.f. We are in the patch F. That means, but when you are the owner of the license, all the patches that we release, and we used to release a new patch every between 3 and 5 weeks, usually less than a month, and around a month or less, we release a new patch with new features, sometimes new modules, sometimes new regulations are included. I mean, you don't have to be updated every single time that we release a new patch. I mean, if you have the 2014 version, all the patches, and I repeat, all the patches that we release for that version are included. Then you can download it with your license from the website, and it will be updated automatically free of charge, obviously. Okay, and the answer will be yes. We are working to implement that regulations. Okay, well, this is the one final thing. This is the structure that we see today. This is the example, simple one. But I wanted to show you also that you can see how it works, the software. I want to make some kind of modifications on the software, on the project, sorry. Now, in a couple of minutes, here we are 5 o'clock, and I go to do very, very fast some modifications. But also you can see how easy it is to do modifications and how we can work it, because it's very common to do that. Okay, I come to beams. I want to delete beams. I want to delete this one. Yes, I have to analyze again. This one. I want to introduce a sloped floor, 3 points, the phenom floor. I want to don't have the snapshot. Okay, like this one, and like this one, and minus 1. Here and here. Okay, I want to come to the second floor. Now I'm in the second floor. I want to introduce as a terrace, for example. I want to define a beam. I use orthogonal, and I want to do it like that. Okay. And here I want to extend beam like this, like this, like this. And I come here and I want to delete like this. Okay, I have the terrace. Also the slab. I want to copy this slab with all the elements here. Also, I want to introduce here a corbed beam, for example, that something quite bizarre. Here, like this one, and like this one. And here on the slab, I want to introduce an opening. And I come for the first floor. And on the first, here, yes, I have the stairs. And I can introduce here, stairs, new. We can tell the type of spans. I can select import from library, stair Cype, like this one. And also I use orthogonal, and I can introduce here and here. Okay, and I can see automatically, and I can see here stair. I want to see the detail of the stair. Yes. You see, automatically I introduce the stair. I have all the details for the stair already, the drawings and all the forces, all the reinforcement, all the calculations. Very, very, very easy. And also here I want to do the analysis, exact foundation, to do it a little bit faster. Now you already see that I edit, and also I delete some beams. I introduce a sloped floor. I introduce a new stairs. I introduce a terrace, a corbed beam, and then you can see how easy we do it, and also the results, with also all the complete detailed drawings every time that we can have it. Here I come to the results, and I want to see, for example, I want to introduce also stairs, for example. I can accept. I want to cancel, let me see. I want to import some, I do it sometimes want to do it very fast. Okay. Drawings, okay. New one also. I want to introduce the stairs here and accept. Okay. Because I cut the analysis, but I don't have to do it. My fault. Here I have now here I have all the details for the new structure. Here, for example, here I can see that I introduce here the terrace, the balcony, the corbed beam. Here are the beams. Also, I can see here the sloped floors that I introduced it already. We introduce, and we have automatically. And here the stairs as well. With the spans. Well, you see how easy we make changes in the structure. Like that. How easy we introduce here the elements by materials. This is a very, simple example, but I want to show you a couple of real examples. For example, that it could be this building This is a real building. This one is from Dubai in Emirates. Already built it. And also they do the same building also in India. I mean, they use the same project in two different places. We only have to change the regulation, do the analysis, and there's the same project works in both places here. And I want to show you 3D view. Here you can see what I can introduce my materials. In this one, the problem, the difficulty was the span, because here they have a very big span in every single, without columns, in every single floor, and also this on details of this aesthetically. And here they have three underground parking floors, and here will be the entrance for the parking. And this is for the elevator. And for example, to see bigger projects, this is also a 27-story building. Then also that in the beginning also you ask for type of works or the size. We can achieve all kind of projects. And this will be a 27-story building like this one. In this case, it was used by pipe caps. Okay. Also that you can see, all type of projects that we can handle it. Okay. Well, I don't know if you have any more questions that I can answer to you. If it's not any other answer, we can finish this presentation to give in to all of you. Thank you very much to attend, to Mr. Raluca, Mr. Ovidio, Mr. Oltean, Mr. Farkas Robert, Mr. Dani, and Mr. Catalin. Mr. Catalin, Mr. Florea, Mr. Ovidio Florea, he will be in charge of the pricing for the license. It depends how many license. Probably he are in position to do kind of offers. I'm on charge of the area, but the person on charge for Romania market, it will be Mr. Florea. Then I suggest you can contact to them. Anyway, if you have any kind of technical questions or technical doubt or whatever that you want to know, this is my email that also you can contact to me, and we can try to answer if you have any kind of doubt or questions or whatever you want to do. Any of you, thank you very much. Any of you have other questions, then I want to say thank you very much. And as I repeat, Mr. Florea will be on charge for the Romanian market. Will be probably very soon, personally, probably I will be very soon in Romania. I hope in the first half of this year. And we are implementing, and we are working to implement it, but right now our software is already 100% to work in Romania, and we are still working to make some improvements in our software in the next months only for Romania market. Well, probably you understand much better what Mr. Florea said. I'm very sorry. And well, thank you very much, and we keep in touch. It's okay for you, Mr. Florea? Okay. Thank you very much. Good afternoon. Bye-bye.